Here's another sample problem. So this is on the website. So again, the answers are given. The answers are given on our webpage. If you can't get them, I'm going to go through every step of the problem here. So first, let's set this problem up. And the best way to start is to draw a diagram. This helps me visualize what's going on in the problem. It helps me understand which variables are horizontal and which variables are vertical. So the question says, what's the farthest jump a motorcycle can make off a 15-meter high cliff if it leaves with a maximum horizontal velocity of 70 meters per second? And this should say, or this should specify, that the velocity is entirely horizontal. So if I gave you this on a test or quiz, it would come with a diagram. Wouldn't necessarily be a good diagram, but there would be a diagram that looks like this. So you have it leaving a horizontal, so we're still doing horizontal launches here. And it would be 15 meters high. And here's a motorcycle that would be going at some horizontal velocity off this cliff. Okay, and there's a rider on the motorcycle. And you want to know, maybe he's going to jump a pit of sharks, or who knows what he's going to do. You want to do a trick here. You want him to be able to jump some distance. You want to know, well, how far can he jump? If he's traveling at this horizontal velocity of 70 meters per second, which is pretty fast. So the first thing we're going to do is set this up in terms of, what do I know, what's going on along the horizontal, what's going on along the vertical. So I'm going to list my x variables. I'm going to put CV here to remind me this is at a constant velocity. There is no force along the horizontal. This is a free fall problem. And we're considering this motorcycle and the rider a projectile, which means they are only acted upon by gravity. And gravity accelerates things downward. So the force that's accelerating the motorcycle and the rider is acting downward. So this is constant velocity along the horizontal. What do I know? Well, I know that he's traveling at 70 meters per second along the horizontal. I'm not going to put initial velocity or final velocity or average velocity, although it is the average velocity. And it is the initial and the final velocity. It is a constant velocity. He goes 70 meters per second horizontally during this entire event. I know my unknown is delta x. I want to know, if he's going 70 meters per second, how far can he go? And I know that depends, or how far will he go horizontally, and I know that depends on for how long he's going 70 meters per second. If he goes 70 meters per second for 1 second, well, then he can go 70 meters. If it's for 2 seconds, he can go 140 meters. If he travels at that horizontal velocity for 3 seconds, he can go 210 meters. So he's at a constant velocity, and the missing information here, what I need to find out, is time. And I'm going to use my y information along the the vertical along the y-axis. He's in free fall. That's all that FF means, is to remind me he's accelerating at a rate of g. G is always downward, and it is 9.8 meters per second every second. What else do I know? I know that he starts here, and he's going to end here. And so his vertical displacement, that delta y, is going to be 15 meters. Relative to where he started, he ends up 15 meters below that point vertically. His displacement is down, so delta y is down 15 meters. This point's down and this point's down. I don't have to make downward negative. I just have to make sure all vectors that point in the same direction have the same sign. I can make it positive or negative, doesn't matter. If I made g negative, I would have to make delta y negative in order for this problem to work. I'm not going to do that. I don't make things negative unless I have to. What else do I know about the vertical direction here? I know that initially all of his velocity was horizontal. So I know his initial velocity in the y direction was 0. This problem, when I find out how long it takes him to get to the ground, it's just like saying, well, you dropped him. You know, you dropped this motorcycle 15 meters above the ground. How long will it take to hit the ground? And again, in a free fall problem, if we're neglecting air resistance, it doesn't matter if it's a motorcycle or a feather or anything. You could drop anything, a Volkswagen. It will hit the ground at the same time. It will take the same amount of time. So here I have two things going on. What variable is in common for both x and y, and that is time. The event begins when this motorcycle drives off the cliff, and the event ends when the motorcycle lands hopefully safely on the other side. So it takes the same amount of time for the motorcycle to go down this 15 meters as it does for it to go across however many meters it goes across. So time is in both columns. Time is does not include direction. It is a scalar quantity, and so it wouldn't naturally fit into either column, a vertical column or a horizontal column. And we also know, just thinking about this, that the horizontal displacement, this delta x, takes place over the same amount of time as delta y. How am I going to find time, which I need to find in order to find displacement here? I'm going to use my information along the vertical. I have acceleration, I have displacement, I have initial velocity. Can I use that to find time? Yes. So let me just write that over here somewhere. Find time. I'm going to use the y information, and this is the equation that I'm going to use. I put a y there. So delta y is just displacement. I'm calling it y because it's vertical displacement, and I want to distinguish it from my unknown, which is the horizontal displacement. V naught in the y direction is 0. This thing goes off the cliff horizontally, so this is 0, which makes that whole term 0. Acceleration, instead of 1/2 at squared, I put 1/2 gt squared. Acceleration is g, and that is 9.8. So what is the time when I isolate this? And if you don't know how to isolate this, I think I do in the video right before this. You can go back and see where I get this, how I go about this. You can ask me in class if you still don't get it. 2 delta y over g. You could also say delta y, the square root of delta y over 1/2 g, you would get the same answer. Multiplying by 2, dividing by 1/2, same thing. This would be 2 times 15 meters over g. And notice that the displacement and g have to have the same sign. If these were both negative, I would still end up with a positive underneath this radical. And so everything would be fine. So just make sure you give them the same sign. I made them positive in this problem. You don't have to write the positive sign. When I solve for this, I get 1.7 seconds. So I know that this takes 1.7 seconds. What did I just figure out? I just figured out if an object is dropped from rest 15 meters above the surface of the Earth and it accelerates at a rate of g, how long will it take it to hit the surface? And the answer is 1.7 seconds. That's what I just calculated. So since it takes this 1.7 seconds, in 1.7 seconds, the motorcycle's on the ground. During that 1.7 seconds, it's traveling horizontally at 70 meters per second, and I want to know, well, how far does it go? So I can answer that question. Now I can find delta x. I'm going to use my constant velocity equation here, delta x over delta t. Delta x, I would just multiply the t from both sides, or by both sides rather. Now I substitute. The horizontal velocity is 70 meters per second, and the time is 1.7 seconds. And when I do that math, I get that it went 120 meters. So during that 1.7 seconds it took to hit the ground, it traveled 120 meters. Could I get it to go farther? Sure. I just have to make it take longer to hit the ground, and it would go farther. I could have it jump from a higher cliff. I don't know how the motorcycle rider would do when he landed on the ground if he went off a higher cliff, but I could. If I wanted this to go even farther, I could fire it from a higher height, and you can do that if you want. You can see, well, how far would it go if I upped this 5 meters or 10 meters or whatever? But right now, off a 15-meter cliff, it's going to go 120 meters if it starts at 70 meters per second. So I've done that. This is done. Part 2 of this question says, with what velocity will it hit the ground and at what angle? So now let's work at that. I'm going to erase this other work I did and make room for that. So with what velocity did it hit the ground? It's going to be going horizontally, I know. This object's going to be going horizontally at 70 meters per second. How do I know that? I know that because the horizontal component of velocity is constant. Remember, there is no force along the horizontal. If it starts at the beginning of this event, if it's going 70 meters per second, it goes 70 meters per second the whole time. There is no force along the horizontal to change its motion. I want to also know how fast is it going vertically. So this is my horizontal component of motion, and I know that that is 70. And the first thing I have to do is figure out what's its final velocity in the y direction. Then I need to use the Pythagorean theorem. Let me actually put my unknowns in a different color here. I need to use trig to find out the angle of impact, and I need to use the Pythagorean theorem to find out the final velocity. The final velocity, when this actually hits the ground, its speed will be the vector sum of the horizontal component of its velocity and the vertical component of its velocity. Can I find out what its final velocity would be? So again, I'm going to look in this, yes I can, and I'm going to look in this column here where I am given acceleration, I am given displacement, I'm given initial velocity, and knowing those three things, can I find final velocity? Sure. So this is now my unknown. Can I use this time I calculated? I can. And sometimes I'll have to. Sometimes there will be no way to get this answer without it. But wherever possible, remember, I like to not use anything I calculated in case I screwed up. So now let's find the final velocity in the y direction. What equation am I going to use that has acceleration, displacement, and initial velocity and final velocity? And it is this one. And let me just put my y's in here. And again, this helps me this helps me grade it, but mostly it helps you see that this is going on along the vertical and not the horizontal. I want to solve for final velocity, so all I have to do to isolate that variable, which you still have to do, and a lot of you aren't doing this, is take the square root of both sides, right? I don't want to know what the final velocity squared is. I want to know what final velocity is. Now we're going to substitute. I know this v naught is 0, so I don't have to write that. You can, I don't care. G is 9.8, and y is 15 meters. Take the square root of that. A lot of you are forgetting to take the square root, so you're writing this. You're even showing the step where you isolate it with the square root, and then as you go, you're not taking the square root. I don't take off a huge amount of points for that, but just be careful. Just check your work, do it slowly enough and neatly enough so you can make sure you're doing the right calculations as you go through. When I put that in my calculator, I get 17 meters per second. So that's the final velocity in the y direction. So I can put that in. This equals, I'm going to put it up here, 17 meters per second. So I have a right triangle with legs of 17 and 70. So this thing is falling downward at a rate of 17 meters per second while moving sideways at a rate of 70. Can I find its final velocity? And sure, I use the Pythagorean theorem. Final velocity, a squared plus b squared equals c squared. This is the hypotenuse, so this is c, so it's going to equal the square root of this plus this. This squared plus this squared. So 17 squared plus 70 squared. If you're having trouble with the Pythagorean theorem, somewhere on this website is a video with lots and lots and lots of Pythagorean theorem questions, so you can go take a look at those and see how it's solved. 72 meters per second is the final velocity overall. And now the last thing I want to do is find, well, at what angle does it hit the ground? It doesn't fall straight down, right? The motorcycle is not going to fall straight down like that. It's not going to hit straight across like that. It's going to be at somewhere between those two. And I want to know at what angle is it going to hit the ground. So this is just a trig problem. I have a right triangle with legs 17 and 70. I can use a 72 if I want, but again, if we can avoid it, we will. So relative to theta, this is theta. This 17 is opposite. The 70 is adjacent. I'm going to use the tangent function. So here's my last thing I'm going to do is find theta. Theta is the inverse tangent of opposite over adjacent. I should write up here tangent theta is opposite over adjacent, right? That's that TOA and SOHCAHTOA. So opposite over adjacent, I'm going to use tangent. Tangent equals opposite over adjacent. Theta is inverse tangent of opposite over adjacent. A lot of you are still writing very funny things when you try to show the steps. So that's what you're saying. You're saying this angle is the inverse tangent of that ratio. Plug it in. Opposite is 17. Adjacent is 70. And we get that it hits the ground at an angle of 14 degrees.